Welcome back. In this video, we are going to talk about how Spring handles cross-cutting concerns like transaction management, security, using aspect-oriented programming and proxy design pattern. First, let us understand what do I mean by cross-cutting concerns and how AOP is going to help us. Usually in our applications, there will be business requirements. Let us take an example of an e-commerce application. So we may get a requirement like create order, cancel order, or update user profile. So those are the business requirements. And if you take a create order use case, it may involve doing multiple subtasks. For example, for creating an order, you may need to insert a record into orders table, a set of records into order details tables, things like that. So you expect either you do this operation entirely, or if there is any problem, don't do any of these things at all. Like this is nothing but a transactional atomicity, right? So these are not the requirements by itself like transaction handling, but they are complementing to the business requirements. Like when someone says create order, you should either do it completely or you don't do any of those operations at all, right? So similarly, there are requirements like security. Considering all these operations like create order, update user profile, or cancel order, they are supposed to be done by authenticated users only. So you need to perform a check whether the user is logged in or not while performing any of these operations. So that way, these features like security, transaction management, etc., they themselves are not the requirements, but they are the requirements that span across and used along with all other business requirements. So these are called cross-cutting concerns. You need those features, but you use them along with the business requirements. Now let us take a look at how we can possibly implement such features. So here we have a customer object with just ID and name properties, and we have customer service with a couple of methods, create customer and update customer. And here we have simple logic. We don't have actual logic of inserting data into database, but we just log saying that create customer and update customer. So here I want to maintain transactions, right? So how do we maintain database transactions? Usually if you are familiar with Spring or Spring Boot, you simply annotate either at the class level, like you use at transactional, or you can annotate specific methods also. And Spring is going to handle the transactions for you. So how does it do? How does Spring manages transactions? By simply annotating with at transactional annotations, right? So here comes the proxy design pattern. For example, if you are trying to apply these cross-cutting concerns across existing logic, you can use this proxy design pattern where you create a proxy on top of this customer service and intercept all the calls before calling the create customer. You start the transactions and then execute the create customer logic by calling this method, and then commit the transaction if everything goes fine. Otherwise, you roll back the transaction. So that all that logic of transaction management, you put it in the proxy object, and the actual logic is going to be delegated to this actual logic that you wrote, right? So let us see how it would look like if you create a proxy by yourself. So here, if you take a look at this customer service proxy, we have a delegate object, which is nothing but the customer service. And we are instantiating by passing this customer service instance. And we have the same methods that are there in the customer service, like create customer and update customer. And whenever somebody calls create customer, here we have the logic something like, first, we are going to start the transaction, database transaction, and then make the create customer call delegate to the internal delegate that we hold, which is going to execute the actual logic that we have in our customer service. And then if everything goes fine, we are going to commit the transaction and return the result. If this actual logic throws any exception, we are going to roll back the transaction. And finally, we are going to close the connection, database connection. Same for update customer. Whenever somebody calls update customer, we are going to start database transaction and call the actual update customer logic that we have in our customer service. And then if everything goes fine, we are going to commit, or if there is any exception occurred, we are going to roll back. And finally, we are going to close the connection, right? So it is how we can create a proxy, and let us see it in action, like how it would look like. So here we have a simple main class and we have customer service object created, and then on top of it we have customer service proxy, and we pass this customer service object as a constructor argument to this proxy, and then we created a customer object and then call create customer. Okay, so now if I execute this, so here in the log we can see we are starting the database transaction, and then the actual logic create customer is executed, and it is going to commit the transaction and close the connection. Okay, and if you take a look at the logic here in create customer, if the ID is not 0, we are going to throw invalid customer ID runtime exception. Okay, let us change the logic here and let us make it 1, customer ID 1, and then we are calling create customer. Okay, so here we can see it started the transaction, but an exception is thrown from the customer service because ID is not 0, and then it catches the exception, the proxy catches the exception, and then it rolled back the current transaction, finally close the connection. Here we can see the log. Okay, so if you take a look at this customer service, it is completely unaware of any of those transaction management logic here. You don't see any of that logic in this customer service itself. All that database transaction handling logic is there in the customer service proxy. Okay, but if you have to create a proxy for every class or every service you have, it's not practical, right? You end up creating a lot of logic, and also if you take a look at this, it's kind of a lot of boilerplate. You do the same transaction handling logic across all the methods, and then implementing the proxies like this is just not practical. So, but there is a better way to do it. Like Java offers JDK dynamic proxies in the core JDK itself. Okay, now let us take a look at how we can implement the same thing using JDK proxies. Okay, let us take a look at how we can create a proxy using JDK dynamic proxies feature. So here I have created a class called transaction JDK proxy, and I have implemented invocation handler interface, and I have make it as a generic argument so that we can use it with any class, not specifically for customer service. And we are going to pass that generic object, and we are going to hold it in the target variable. And then while implementing this invocation handler, we need to implement this invoke method. So here I have the same centralized logic of transaction management. Before executing the actual method on the target object, we are going to start the database transaction and then execute whatever the method that caller is trying to invoke, and then commit the transaction. If there is any exception occurred, we are going to roll back the transaction and finally close the connection. So this is the same logic we have in our handwritten proxy, but here we are leveraging the JDK dynamic proxies. Like this, you can create a proxy, and then how we can use this. So here I have created a new method called use dynamic JDK dynamic proxy, and we have created our customer service object, and then we have created a transaction proxy by passing that customer service object, and we have created. And one more thing is, in our customer service, we have implemented an interface called iCustomer service, which has these create customer, update customer methods. And coming back to our JDK proxy, into the main method, this is how we can create a proxy for our customer service. What we are doing, this is JDK proxy class and creating a new instance, and we can pass the class loader reference, and then we need to specify what are all the interfaces that our target object is implementing, and then pass the transaction JDK proxy that we just created. So here is the catch. While using JDK's dynamic proxies, our object needs to implement interfaces. Otherwise, it cannot create these dynamic proxies. So that is a limitation. Then once we have this customer service proxy, once we create this new proxy instance, it's going to be a generic object instance. That's why we need to cast it into our interface type. So once we have that reference, we have created a customer object and then finally called create customer method. So now let us execute and see. Okay, because here we have passed ID as 1, it's going to throw exception according to the logic in our create customer, and then you can see the logic start transaction and then failure occurred. That's why we are rollbacking the transaction and closing the connection. Let us change ID to 0. Here ID to 0, and now it just started transaction, created the customer and committed the transaction, closed the connection, right? So it is just like the way we have written a proxy by hand, but instead we don't have to create a proxy class for every service. We can just reuse the same proxy creation logic here with any service. So similar to, once we create this, and we can use as if we have written by ourselves, right? You can use the same transaction proxy with any service you created. But a limitation to the JDK dynamic proxies is that whatever the object that we are trying to create a proxy for should implement an interface. Let us take an example, like here we have a person service, but it did not implement any interface. So we cannot use JDK dynamic proxies to create a proxy for person service. So that is where we can leverage other libraries, like there is Cglib library, which is being used by Spring internally, and also there is some newer library like ByteBuddy. So these are the libraries that we can use to create such proxies. But as of now, Spring internally uses Cglib library to create these proxies, so that it doesn't have to implement any interface. So using Cglib, you can create a proxy for person service or customer service. So there is no requirement of you should implement any interfaces. Now let us take a look at how proxy creation looks like with Cglib library. So here I have a transactional Cglib proxy class where I have a method called create proxy, which is taking an object for which we are going to create a proxy for. And then we can use this enhancer class and then set what is the base class, super class that we are going to create a proxy for. And then we are setting a method interceptor here. It kind of look very similar to what we have seen with JDK dynamic proxies. And here we have a reference to the target object and method reference and arguments that are passed to that method. So the logic is very similar here, like we are going to start the database transaction and then delegate the actual logic to the actual target object and then commit the transaction if everything goes fine. Otherwise we are going to roll back and close the connection. So this logic is same, and the benefit is with Cglib you don't have to implement any interfaces to create a proxy for. Okay, So now let us go back to our main method, and here is a method that uses this transactional Cglib proxy. And we have created a customer service object, and then we instantiated transactional Cglib proxy class, and then we called a method create proxy and passing this target object, which is customer service instance. So once we have this proxy, we have created a customer object and then called create customer method. So let us call this and then see. It should behave exactly same as before. Like it started the transaction, create a customer and commit the transaction. And if the ID is not 0, it should throw the exception and roll back the transaction. Okay, so it is working as expected. And the benefit is, as I mentioned, it doesn't need to have any interfaces implemented. For right now, we have customer service implements customer service interface, but there is another service, person service, which is not implementing any interface. Let us see whether it is going to work or not. Okay, let's go back to, so here instead of customer service, let us use person service. Okay, so here let us call person service, and it is working just like the way it worked for customer service. Like we have create person and then simply logging this method, and transaction handling is working just like it worked earlier. So here there is no need for implementing any of these interfaces. Now Spring is internally using this Cglib proxy. If you go to Spring core library, you can see, let us just take a look at Spring core library. Here, so if we expand this, we can see Spring is internally using Cglib library. They have actually embedded so that they can maintain their version without breaking any changes. So behind the scenes, Spring is using Cglib proxy for creating these dynamic proxies. Now, because of these facilities, it became very easy for us to maintain the transaction. All we have to do is just add this at transactional annotation. And then, like we see in the earlier videos while discussing about the dependency injection, when Spring starts the application, it scans for all the beans that it needs to create instances for, and then using reflection they can identify what are all the methods has at transactional annotation. And while creating an instance for this customer service, instead of just creating the customer service instance, they also create a proxy for it, and then inject that proxy into the other places. Like suppose if we are using customer service in a customer controller, instead of directly injecting the customer service instance, they inject the customer service proxy instance, so that when they call a method like a create customer, they are not actually calling that method directly on this customer service. Instead, they are calling create customer method on the proxy, so that all this transactional logic is being executed and then finally delegates the call to the actual logic, and then transaction is committed or rolled back. So that is all transparent to us. So we simply annotate the class with class or method with a transactional, and Spring takes care of executing all the transaction. Or in fact, security is very similar. Like you might have a controller that has pre-authorized annotation, something like that, and Spring uses the same concept of scanning for this annotation and then creating a proxy and then do whatever the logic is required, be it a transaction handling logic or checking for security. So like that. And now let us take a look at how it would look like. So here is our target object, which is nothing but our actual customer service instance. So here we have a couple of methods. which doesn't have any logic about transaction management or security or anything at all. Okay, and then when Spring starts the application, it checks that it has either a transactional annotation at the class level or method level. So it understands that it needs to create a proxy for it. So it will create a proxy using Cglib, and then it inject the logic into this proxy, and before calling any of these methods, it should start the transaction and delegate the call to the actual target object and then commit the transaction. Okay, so that is how Spring handles all these cross-cutting concerns like security, transaction management, or even logging. All these things we can implement using this proxy design pattern. And where does this AOP comes into the picture? So AOP, aspect oriented programming, is nothing but a programming paradigm to implement these cross-cutting concerns using a modular fashion using proxies. So Spring internally uses this Cglib to apply all those cross-cutting concerns. Okay. Let us talk about an interesting scenario where many people misunderstand this concept of proxy. So here we talked about how we have a target object, which is the actual instance of our service. Let's take an example of customer service. And then Spring takes care of creating a proxy on top of it to take care of transaction handling. Okay. So now let us say there are transactional semantics of where by default, if you simply annotate with @transactional, Spring will check if there is any transaction in progress. If so, it's going to continue executing this logic in the same transaction. Or if you have an annotation like @transactional with propagation as requires new, it's going to start a new transaction. Okay, so let us say we have annotated update customer with propagation level as requires new, and this create customer as simply transactional. And I know it doesn't make any sense to call update customer from create customer, but just for the sake of discussion, let us call update customer. And then when people call create customer, they assume okay, it's going to run in a transactional context, and when we call this update customer method, it's going to start a new transaction because we annotated with a transactional propagation requires new. It's going to start a new transaction and then execute this logic, and if this successfully completed this update customer logic, it's going to commit the transaction and then come back, and if there is any failure in this method after this method call, only the changes in this create customer after this update customer will be rolled back. No, that's not how it works, because if you take a look at this diagram, once let's see how this gets work. Let's say we have order service, and then Spring creates a proxy, and then we have injected order service into the order controller. But in fact, what is getting injected into order controller is a proxy, not the actual order service. Okay, so from order controller, when you call any method on the order service, you are actually calling a method on the proxy. So, and proxy knows that it needs to start the transaction or commit the transaction because we annotated with @transactional, and Spring is capable of reading the what is the propagation level. By default, it is just requires, so it knows to start a transaction when you are calling a method on the proxy from your order controller. But once you call a method, okay, let us say we are calling a method create user, and then you entered into the logic of this create user in the target object, which is nothing but our actual customer service here. And when you make a call to this update customer, you are simply calling this method from this method. So it doesn't have any visibility of this, what is the transaction propagation level, nothing. It doesn't have any of that concept of transaction here. So you are calling another method from the same instance. Okay, if this method is being called from another class, it is come through proxy, so that it knows that it needs to start a new transaction because we have propagation level as requires new. But when you are making a call from the same classes another method, it's not going through all those transaction semantics and then check for what is the propagation level. So when you are calling another method from another method in the same class, it's not going to check what is the transaction and all these things. Okay, so keep this in mind and don't misunderstand that just calling another method would apply these transactional semantics. I hope you understand how Spring implements these cross-cutting concerns using AOP and proxy design pattern. Stay tuned for the upcoming videos. Thank you. Bye bye.